Hi everybody, my name is Omid and I'm going to show you how to simulate complex cloth using TAngra GPU Cloth Solver based on user requests. For this demonstration, I created a tennis serve that I believe it's a good example for what I intend to do, as it contains fast and complex movement and neat complex self-collision solver. As you can see, animation is not my strong suit. Most parts of the animation need improvement, especially hands that should be rotated. By the way, this shouldn't have any effect on simulation. Returning to animation, I added a T-pose at the beginning of the animation, which is necessary for cloth simulation. It gives the cloth enough time to match the body shape before actual movement starts, providing a good starting point. Generally, something around 30 or 50 frames should be more than enough. Okay, let's continue by importing cloud model I've prepared in OBJ format. Okay, where is it? I can't see that in viewport. Maybe it's too small inside the body. Oh, here you are. It's too big. I need to scale it down to something like 0.1. That should fit. Let's go back to the first frame and see if it fits the body. This is a static mesh that I'm going to use as cloth. To get the best results, we need to be sure there is no intersection between body and cloth at the first frame. Also, as I already mentioned, we should have about 30 to 50 frames between T-pose and the start of the animation. To start simulation, I'm going to use TAngra by simply opening TAngra node view and create a new TAngra node system. Then I'm gonna need an input geometry node, collision, and GPU Cloth Solver node to get started with. GPU Cloth Solver is still in beta, but is far more efficient and accurate than existing native physics simulation in Blender, despite Python's performance bottleneck. Next, I need to select cloth as input geometry and connect it to fabric slot. Before connecting it, I prefer to add a cloth property node so I can define the cloth type and customize it. It can work without cloth property node, but it's gonna have default garment properties. In order to change garment type and properties, we can use fabric property node. Before continuing, let's take a look at the cloth topology. Cloth model is a bit dense and more of a triangulate garment. By the way, I'll show you how to change the topology to quad-friendly type later in tutorial. To get a better result, I prefer to use accurate preset. Naturally, it can get slower than normal profile. We can get even more accurate results by increasing sub-steps and add a bit more steps for self-collision. Remember, adding more sub-steps means it's gonna take more time too. Next step is to select the body as collider object and set collision variables as needed. I'll go with these settings. We can do it in any order we want. That's all we need. It's done. At this point, we can play and see the simulation. However, it's not a bad idea to add a cache node so we don't have to simulate it every time. I prefer MB cache for this particular type of simulation because it can be transferred easily to other softwares. I typed in double slashes as the current project path. Of course, we can change the cache path to anywhere we want. At this point, we're done. We can start simulation just by playing the animation. So let's start the simulation and see how it goes. Oops. I forgot to pin the shorts to the body. Okay, let's fix that. But before adding the pins, let's see if the simulation works correctly and if we need to change any other things at the same time too. Uh, as I can see, everything's fine and we just need to add some pins to the shorts. Okay, to add pins, I need to go to the edit mode and let's hide the part that we don't need and it's on the way. Uh, then just select the vertices that we need. Let's do that in all way. Yeah, that's much better. For adding the pin group, we just need to change the type of the pin to selected vertices, and that's it. Now we can unhide everything, and let's double check everything before I start simulation again. I believe everything is fine. Let's play and see the results. Hopefully this time short won't fall. Okay, this is starts good. I believe this is a good simulation. As I can see, there is no glitch, nothing passed through each other, and the collision system working perfectly, especially with this kind of fast animation. The slowness inside the viewport, it's not about the simulation or Cloud Solver. It's mostly because the only way to interact with Blender's viewport and UI is through the Python, which is a huge bottlenecking performance. Of course, after loading cache instead of simulation, we should not see any more problems. By the way, it's fast enough, and I'm investigating the way to make it even faster. At the end, I'm pretty happy with the simulation. Okay, now let's talk about topology. Uh, I'm going to edit mode to show you the current state of the object. As you can see, it's a dense model with a garment type of topology. And if we want to change that to more friendly quad type, I need to use TAngra Remesher node with the quad mesh selected as retopo type. The process is gonna start as soon as we select quad mesh option, and the progress can be monitored in Blender's status bar at the bottom. We should be able to see the result after the progress is finished. Okay, that's much better to work with if you need a quad mesh, of course. It's still a bit dense because quad are determined by the smallest distance between curvature, and for such fabric and the movement, it will remain dense unless we decimate it again. And to make it more curvy and smoother, we can add subdivide and a smooth modifier on top of that. Okay, it has a fair quality. I like the quality of the simulation. Uh, To make it even more interesting, we can add a force like wind, position it as needed. So let's create wind and see the effect on the code. Uh, I'm positioning it in the right side of the object. And in general, I start with a strong value for the wind and adjust the parameters as I go through the simulation. So let's try that. Okay, maybe 1000 is not a bad start, but I believe it will be strong. So if I play it now, okay, uh, it's too strong, but we can clearly see the wind effect on the cloth. Maybe if I reduce the wind strength to 200 or something like that and change the position of it to more conventional direction, it can give me a better result. So let's try that. Okay, that's much better. I can see the wind effect and some ripple on cloth in the middle. That's good. Wind adds small details that will make the cloud movement more realistic, and that's exactly what I'm looking for. My goal is to create a tool that is not only easy to use, it's highly customizable and works seamlessly with Blender, maybe similar to ice in XSI. TAngra is a multi-physics solution for Blender aimed to help users in dynamic and VFX area. It's super easy to use and come with many samples and presets, as well as a large library of pre-made simulation assets. And it's multi-GPU accelerated, so you can use as many GPU as you have to speed up your process. Of course, I need to mention I limited it to maximum 8 GPUs at the moment, as with too many GPUs, the performance can be a little bit tricky because of all sharing the data between GPUs and the acceleration is not linear. It's the nature of multi-GPU process. I hope you enjoyed this video. My name is Omid, the creator of TAngra Multiphysics Engine. Please consider to subscribe to TAngra YouTube channel and join our Discord server for more information. Let's have a final look at the result.